Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see Thevenin's theorem. This theorem is very important concept for both Triple E and as well as EC students, and this is the very basics to solve basic electrical circuits. So this is very important concept which you're going to study throughout your career, and we're going to see what is Thevenin's theorem, what are the procedure to solve the Thevenin theorem circuits, and we're going to see one particular problem in this particular video. So we will start with what is Thevenin's theorem. So Thevenin's theorem states that it is possible to simplify any linear circuit irrespective of how complex it is to an equivalent circuit with a single voltage source and a series resistance. Which means according to Thevenin, he states that any complex linear circuit can be simplified to a small circuit with a voltage source and as well as a series resistance. You can see here this is a complex linear circuit where you have a circuit with many elements and with RL that can be simplified to a equivalent circuit which is called as Thevenin equivalent circuit with a voltage source in series with the series resistance, right? So this is about Thevenin's theorem, right? As I said, any complex circuit, any circuit, irrespective of how complex it is, we can simplify that to a small simplified circuit which is having one voltage source in series with the series resistance, right? And apart from it, you will also have this load resistance, right? So this is the Thevenin's theorem. Now we will see the procedures to solve the Thevenin's theorem, right? So this is very important. You have four steps in solving the Thevenin's theorem. The first thing is you have to draw Thevenin equivalent circuit. We already seen that what is Thevenin equivalent circuit. Whatever may be your circuit, you have to draw the Thevenin equivalent circuit where the Thevenin equivalent circuit is followed VTH followed by RTH, and then you will have a load resistance. This is the Thevenin equivalent circuit for any complex circuit, right? So VTH is nothing but Thevenin voltage and RTH is nothing but Thevenin resistance. So first step is you have to draw the Thevenin equivalent circuit. And the second step, we need to find out VTH. We need to find out VTH. And there is a procedure to find out VTH. First thing what we have to do is we have to remove the load resistance. We have to remove the load resistance and then we have to find out the voltage across this particular AB. Say for example, if you're removing this load resistance, then you have to find out the voltage across this terminal. Right? That is considered as VTH. And then you have to find out RTH. How will you find out RTH? Here, not only load resistance must be removed, you also remove the source. Whereas for finding out VTH, you will only remove the load resistance. Whereas to find out RTH, what we have to do, we have to remove load resistance and also we have to kill the source. What is by killing the source? Killing the source is something where if you have a voltage source, then that should be short circuited. And if you have current source, then it should be open circuited, right? That is what given here. So if it is voltage source, then we have to short circuit, and if it is current source, we have to open circuit it. And now we have find out what is VTH and what is RTH. And the last step is you need to apply, you have to substitute the values of VTH and RTH, and you need to find out the current IL, right? So this is the same procedure for all the problems using Thevenin's theorem, irrespective of how complex the circuit is, right? So now we'll see one particular problem, right? Whereas we'll take a simple circuit here. So you can see here, the question is find the current flowing through 30 ohm using Thevenin's theorem. So this is RL. This is RL, right? So what is the first step we have to do? The very first step we have to do is you have to draw the equivalent circuit, right? First, I'll just explain what are the steps, how we have to solve, and then I will show how I have solved this problem. Okay. So very first step, what you have to do, you have to draw the Thevenin equivalent circuit, right? So what is Thevenin equivalent circuit? You will have a voltage source followed by a series resistance, right? And then you have the load resistance, correct? So this is the equivalent circuit. So VTH we need to find out. right? And RTH we need to find out. And RL they have given. RL they have given us 30 ohm, right? Now, what is the second step? The second step is we need to find out VTH, right? So we need to find out VTH. For finding out VTH, to find out VTH, what is the first step you have to do? You have to remove the load resistance, right? You have to remove only the load resistance. So we see here, we have to take this circuit. We have drawn the equivalent circuit. Why we are drawing the equivalent circuit? We need to find out VTH, we need to find out RTH, and then we have to substitute that values, right? But removing the load resistance has to be done from this particular circuit, the original circuit, right? So to find out VTH, what I am doing, I am removing the load resistance. So if I am removing the load resistance, what will happen? The circuit will become like this, correct? Circuit will become like this, right? So this will be open, right? I am removing this load resistance, correct? So this will be 9 volt and this will be 3, right? And this will be 6 ohm, correct? And now what we have to find out the voltage across A and B, right? This voltage we consider it as VTH. This voltage is considered as VTH, right? So now, if this is voltage across VTH, what need to find out? This is the voltage across this particular resistor. This will be the same voltage across this particular resistor, correct? So now, how will I find it out, right? So now, you can see here, we need to find out the current first of all, right? How will you find out the current? Because we have voltage here, right? So if you find out current, then we will multiply this resistance, right? So we can find out the voltage across this A and B, correct? So V is equal to V is equal to IR, right? And now we will find out I is equal to V by R, right? Now what is V? V is nothing but 9 volt, right? We see from the source side, make it very clear. So you are seeing from the source side, now the current flows like this, right? So now the current flows like this, now this resistance 3 and 6 will become series, right? So if this becomes series, then we will add this particular resistor, correct? So how will you add this particular resistor? It is 3 plus 6, we have 9, right? So what is the current? The current will be 1 amp. The current will be 1 amp, correct? You understand? I is equal to V by R. So it is 9 volt, right? And then we are adding these two resistance 9, right? So we'll obtain 1 ohm. So now the current is 1, right? Now what we have to do? We have to find out the voltage across this terminal. That is VTH. That is VTH, correct? So how will you find out VTH? VTH is equal to, right? So across this particular resistor, this voltage is same across this particular resistor. So this resistor value is 6 into 1. So voltage is 6 volt, right? So this is V Thevenin, correct? And now what we have to do? We have to find out RTH. We need to find out RTH. So how will I find out RTH? To finding out RTH, what we have to do? We have to remove both load resistance and as well as the source, correct? Right? So listen very carefully here, right? So we have to remove the source and as well as the load resistance. So how the circuit will become? Since it is voltage source, we have to short circuit it, correct? And then we have this resistance and as well as this resistance. And we have to also remove the load, right? RL has to be removed, no RL, right? So now you see here there is no voltage source, nothing. So this is the circuit. So we have to approach this for RTH. We have to approach the circuit from this side, right? So this is 3 ohm, this is 3 ohm, and this is 6 ohm. 3 ohm, and this is 6 ohm, right? Clear so far? Now, if you see VTH, while calculating VTH, we have voltage source here. So we approach the circuit from this side. So where this 3 and 6 becomes series. So it becomes 9. Right? Whereas here, this when approaching from this side, right, you see that, say for example, if the current is flowing here, right, the current will get splitted here and as well as here, correct? If the current gets split, then it is parallel connection, correct? So if this is a parallel connection, how will I find out RTH? RTH is equal to, you know, that R1 into R2 divided by R1 plus R2, right? So it will be 6 into 3 divided by 6 plus 3, 6 plus 3, right? So now what will be the value? 18 divided by 9. So it will be 2 ohm. It will be 2 ohm. Now we will find out what is RTH and what is VTH, correct? Right? Now we have found out what is RTH and VTH. Now we have to substitute this value here, right, in the equivalent circuit. So we have already drawn the equivalent circuit here, right? So how will you draw the equivalent circuit? Right, it is VTH. I'll draw it again. So now we need to find out the equivalent circuit, right? We have find out the RTH and VTH, right? So this is the equivalent circuit, right? Now we know that this is VTH. So what is the VTH value we have obtained? It is 6 volt, right? So it is 6, and this is RTH, and RTH is 2 ohm, 2 ohm, correct? Right? And now this is load resistance. Load resistance is 30, 30 ohm, right? Now what do we have to find out? We have to find out IL. We need to find out IL. That is, this is the load resistance, the current flowing here, right? Now we know that V, right? And we have R here. So I is equal to V by R, right? V by R. So how can I put V is 6, and if we have source here, so the current flows this direction. So this will be series, right? So if this is series, then 6 by 32. Right? So now what will be the value? Right? So we'll find it out. 6 divided by 32. So it will be 0.1875, correct? 0.1875. That is the value. That is the current. So what is the IL current? IL current is equal to 0.1875 ampere. This is what we obtained, correct? Right? So now we'll see, this is the procedure, right? So whatever problem they have given, right, you're going to follow the same steps, very simple steps. However complex the circuit is, don't worry about it. If you follow the procedure correctly, then you will get the answer, right? So we will see how I solved the problem. You can see here the same steps I have done. We have drawn the Thevenin equivalent circuit, right? VTH, RTH, RL, and then we need to find out VTH. What I'm doing is I'm removing this load resistance, right? So if I remove the load resistance, I is equal to V by R. So it will be 9 by 9, 1 amp, right? And then VTH is equal to, like, you need to find out 1 into 6, so it will be 6 volts. And then I'll find out RTH. When I find out RTH, I'll remove load resistance and as well as source. So we find out 2 ohm, and then I apply that in the equivalent circuit, and we obtain the same equation. Correct? Right? So today, what we have seen is we have seen what is Thevenin's theorem, what are the procedure to solve the Thevenin's theorem, and then we have seen one particular problem. Correct? I believe this video will be very useful for you. Thank you, my dear students.